Hi everyone. In this session, we'll be covering about the VPA channel of the QCS performance service. Apart from this channel, we have three more channels. Those are control utilization, sensor stability, and transition. A separate session will be done for them. So agenda for this session will be like I will be explaining about the solution. I will explain about the objectives of the service port and the VPA channel, the scope and the benefits of the VPA. And then we have a live demo session where I will take you through the service port demo session where we'll give you how the look and feel of the dashboards are there, how to generate the track rules and the alerts, how we can generate the reports, and based on our findings, how can we implement the changes. In the past, less data was available to be analyzed. If you take an first example, if there is an issue among 8 units, you can find it relatively quickly and in the manual way. But as the scenario changed, the present situation when we have a more data, like if you consider this 300 data or 1000 data, then it becomes a tedious job to find an issue. If you think that this is a red dot is an issue, and if you've been asked to identify an issue between the 300 data points, then it's very hard one. So our analytical engine continuously scan all these data points to more easily find the needle in the haystack and to solve the problem faster way. So we consider this conical filter as an analytical engine where all type of input array data is been fed, and the output is only the actionable data. So the data what we have, like what type of all type of data what is been feeding into the filter. So we no need to see all type of data during the initial step. So one this analytical engine will give the output where we need to take the action and what type of action need to be taken. So based on this actionable data, we can even prioritize that one, then on which one has to be addressed on the top priority and which one has to be addressed on the low priority. So ABB Service Port is a secure remote enabled service delivery platform that allows user to view, scan, track the key performance indicators to ensure maximum performance of equipment and the processes. So key functionality of the service port are you can view, you can scan, track, can generate the predictive alerts. You can even generate the reports for the submission with your findings and the observation. So here is just a basic overview when you open the service port, how it looks like. It has a channel lineup where you have multiple channels configured. The available views for each channel, you can get it in the down over here. It's just an example of how the track summary looks like. I'll be explaining about the track summary in a different slide. Then we have a navigation button, which will be having an option to go to the previous and to the next one. So ABB QCS performance channel is accessed through the ABB service port. This is a service delivery platform that conveniently deployed at the customer location. You can view and operate the channel through a web-based window that is easily accessible by the team members. With the ABB QCS performance service channel, we get the advantage of continuous monitoring the data. It can be analyzed to greatly reduce the time and effort needed to identify the issues with the control utilization, sensor stability on the real variability, which are outside the threshold limit. This data is classified based on specific KPIs to provide a list of problematic items that are then prioritized based on the severity, process area, criticality, or the financial impact. This analysis leads to more informed, more responsive decision making by the team, resulting in better performance. So digital technology accelerates the service delivery and value. The traditional service, how it looks like, what the traditional services does, it ensures the availability, it avoids the plans process and the disturbances, it controls the cost on a short-term basis, and the process improvement services it increase the reliability of the system, it improves the process performance, it also reduces the quality variances and productivity into improvement. But with the digital, we can capture the knowledge fast, we can analyze data quickly, we can improve the performance on continuous basis, and we can sustain it for the long term. So in today's production environment, paper makers depend on the quality control system equipment for the daily operation of their paper machine. To maximize production throughput and the quality, the QCS must also be performing at the peak efficiency. So if a control loops are not tuned or left in manual, the benefit of modern control technology is not working optimally for the paper maker. Also, if a sensor maintenance issues go undetected, this may also cause an unscheduled downtime and loss of production. And if there is a process variation and that is also not get detected, that can also cause a rejection, a more rejection in the paper. So these are the parameters which need to be addressed on the priority. With the QCS, we can definitely reduce the waste and maximize the production time. And with the service of the QCS, we can make a sellable paper. We can optimize the QCS. We can improve the quality. We can reduce the product waste. But with the digital services, what we have the sensor stability, control utilization, and the process variability and the transition, which have their own advantages. So benefit of ability performance QCS performance channels are like it improves the production uptime by optimizing the QCS performance. It accelerates problem solving for sensors, control, and the variability. It saves time and money with automatic grouping and quick analysis of production quality data by grade. It identifies the opportunities to improve the measurement and control performance, which leads to a better paper in a less time. It reduces the response time and travel expenses by providing remote access to ABB supports, which makes troubleshooting in a faster way. It increases the availability of the system. It speeds up the process and improves the product quality. So before jumping onto the VPA, let's see what type of information we are capturing and how those are important. So a scanning sensor, which has been mounted on the scanner, that measure the sheet as it crosses the moving paper, and it generates two type of measurement. One is the profile, which is in the CD, and one is the profile scan average, which is the MD1. Both CD and scan average measurement have update time equal to the sensor scan time, but the sensor scan time is constant and regardless of the sheet trim. Profile CD, it contains multiple data points, which we also called as a data boxes. With each, those are having equal width. The number of data boxes with measurement depends on the sheet trim. So if the sheet trims are more, so the width of the data box will get increased. Or data box measurement time depends on the scan time also and the number of boxes with the measurement. The scan average MD trend is the singular data value equal to the profile average updated at the edge of the sheet. So VPA provides insight into the CD variability, MD variability, MDS, what we call as a residual variability or the total variability. So basically the MDS is related to the noise. If you have any machine vibration and all, that will be detected under the MDS. MDL is like the scan average trend. If you have any process disturbance or the tuning issue in the ND direction, that can be detected in the MDL. If you have a CD, it's related to the average profile. So if you have a profile disturbance or the head box is not performing or the mapping is being disturbed, that can be detected through the CD and the total. So if you consider a normal distribution, in a normal distribution, if you remember, the 60% of the values drawn from a normal distribution are within one standard deviation away from the mean. About 95% of the values lie within the two standard deviations, and about 99.7% are within the three standard deviation. So based on the customer requirement, the 2 sigmas and 3 sigmas can be configured as site. Majorly, it's like 2 sigma it's been used. So how we detected the problem at the site? So first step is to determine if the total variability as a percent of process is acceptable. If it is not, then we will evaluate the distribution energy that makes up the total. So basically these three constituents makes a contribution which makes up the total value. So first priority is to identify the issue with the total. What we do, we use this calculation to derive the sigma as a percentage of process based on that. And once the process of any of the variable is high or any of the measurement is high, then we will see which is more contributing for this variation. Then it's easy for us to identify the issue. But the default percentage of these distribution values for CD, MDL, MDS are 20%, 10%, and 70% respectively. What VPA helps in finding the gap. So when the customer reports, they will have a high product variability, they have a high variation in the MD direction or in the CD direction, or when they see the paper, they can have like high and lows. So this can be a problem which can also be detected with this type of solutions. And it also addresses the issue when the customer says, or any of the one reports, that it's very hard for us to analyze what type from the where the variation is coming or what type of variation. From the customer point of view, if you see, then if the CD variation or MD variation, that it's very hard for customer to distinguish. So with this, we can see with the reports what we analyzed on a every reel generation, we can see from where to address and which action has to be taken either on the CD or MD, or some of the machine parameters need to be fixed. We have historical data as well, so it also solves the concern. We can have a gather data of 2 years as well to analyze it. So with that, we can also we can have a preventive maintenance mechanism which also stops and which also anticipates some of the failures. So how this work is like, VPA channel, it monitors the reel reports which is getting generated at end of the reel. So these reels are normally built up after the 45 minutes or the 60 minutes based on the type of the paper or the reel what we are making. So VPA captures the MDL, MDS, and CD variability. So when we have a paper machine and at the end of the shift, when the reports are generated, it looks something like that, where we have a quality analysis below the production summary at the end of the reel, where we for the each measurement we have the actual value, the target value, the efficiency, MDL, CD, and the total. So with this tool, we will capture all these values. We will also capture the production data for the analysis purpose. So this is the raw data view. So that data view of the QCS VPA channel provides a trend of the VPA data for the selected sensor. So here we can select the sensor, and here we can also select the groups. These groups are nothing, it's like the grade groups. If we have made one group which has been capturing the data for like 50 GSM to 100 GSM, that can be clubbed on one group. That is basically depend based on the how many grade variations we are running at the paper machine. These time periods are also selectable from the daily, weekly, monthly, quarterly, and yearly. So each KPI here, if you can see, we have the each KPI here. Each KPI detail has 3 displayed parameters. So these are the KPI, actual, and threshold. The KPI actual value is always scale from the 0 to 100 for a VPA channel. The KPI is measured percentage. The actual is above the threshold, and it is limited to 100 above the threshold. This one is the event view. So if you can see, there are some grade groupings are done for the 13, 15, 20, and 24 type of paper groups. And this type of KPIs can be detected. So for each measurement, we have almost 12 type of KPIs which can be generated. And based on this KPI, we can see where need to be addressed, which issue needs to be addressed on the priority. This is just an example of one of the customer where we data views displays over several months, and this can be compared for the different grade. The bottom trend includes the CD, MDL, and MDS variability trend. However, the top trend is set up to, so reel actual is the average dry weight for each reel of the paper produced. The top trend can be changed with pull down menu to show the total variability, reel target, reel actual for the selected sensor. So here how the percentage of process helps is like we have a percentage of process checkbox. It is used to show the variability as percentage of the total real actual, and is very helpful to identify when variability changes or stay constant as the average grade changes. So if we are comparing data from different machines or even different grades on the same machine, it can be challenging when using absolute variability numbers. So VPA data is statically by nature and is function of the average component of the process. For example, if a total variability of 2 would mean very different things if the average weight over were 20 GSM versus the 200 GSM. In order to help normalize the problem associated with average value, the total variability can be calculated as a percentage of process. If the variability increases with the real actual increase the percentage of process, it will remain constant. If the variability increases unproportionally compared to the real actual as the percentage of process value will change to reflect this variability change. This is also one of the data from one of the customer side where two years data is been analyzed. Here the customer has seen that CD weight up to the 1 during particular month and reduced to 0.5 after 2 months. So they have okay, the total contribution is the CD1. They might have the CD variations. They've also observed that MDS is reducing after wire and felt change. So they have seen that they could able to optimize the wire life and the felt life, and they can have a optimal value where they can compromise with the quality and the changing of the belt wire and felt. So they can predict when it requires to be changing and from where the problems are coming. So here also one of the example that MDL has reduced from 0.4 to 0.2. So initially it was low and then it started increasing. So customer has an overview data from and they can see what changes has been done in the machine which has impacted this one, or the tuning has been carried out, or it has to be tuned after some time because the system will get, as the system get age, the loop need the tuning. The another powerful benefit of the service port is the track. So service port track rule allows user to create conditional rules to monitor the analysis result for each channel. Each time a rule is violated, the event is recorded in a database on the service port. This rule violation for each channel can be viewed on the corresponding event views. So with this, we can define the user defined notification rules we can define. We can have a visualization parameters. We can send alert through the mail or through the SMS when the KPIs or any data is exceeded as per the configuration. This is one of the best views that we call it as the Pareto view, where the count of the track rule violation is being shown. When a particular track rule is increased, so it is being shown in the bar graph. So based on that, this shows that how many violation has been happened for this particular KPI which has been created here. So it shows that it's been happened on the 46 times and the other violations has been on the lower side. So the priority has to be given on this. Even those others can also be monitored, but those priorities can be put on the later stage. With this, we can also ensure whether the corrective action can be taken during the downtime what we get it. And we can arrange the right scaling value in advance to detect whether this problem is going to happen in coming days, and the early detection with no or less downtime. This is the service pro track summary. It displays the information about the rule violation. Here the trends are there which has been monitored and allow user to choose specific trend to analyze further. If for instance a trend appears to be outside desired operating parameters, this also indicates like how many violations has been recorded on a particular day. So the top bar is like for the medium, the red one is for the high, and the blue one is for the lower one. So as this highlighted date is there, and it shows that the violations for the medium one has been four violations has been detected. For the high one violation has been detected, and for the low priority rule, one violation has been detected. Same has been displayed on the bottom one. So based on that, we can have like which track rules has been exceeded and which are outside the desired operating parameters which has been configured in the system. This is one of the part of the scan view track view where we have the log view. The log view is available for a more filtered and detailed look at a rule violation that have been previously detected. So we have a filter over here where we can select if you want to have a look on the high priority. If you want to have a look, then we can just check the high priority filter and we can have a look over there. We can select a particular date range, or we can also filter based on the rules which we have configured over here. Based on the track rule what we generate and based on the alerts what we create in the system, we will get a email which indicates when the problem has been occurred. We can configure this email based on the requirement, like when the KPI or any data exceeds, it can send an immediate email on the immediate basis, or we can have a daily summary, or we can have a weekly summary of the email in our mailbox, which helps us to recognize the problem in a faster way, and it helps us to take a proactive actions before any problem arises. This is the counter plot. The counter plot figures provide visualization of KPA average for each weekly analysis over the scan report data range. The x-axis designate the time period with the start date on the left and the end date on the right side. A dark patch indicates a problem area where KPI is close to 100, and a lighter to the white patch indicates a sensor that is very close to or meeting the VPA limit, which is like KPI close to 0. Each horizontal sequence of patches represent a particular sensor group KPI over the scan port time period. This is the severity bar chart. It provides a summary of the top 12 sensors grouped with the VPA issue. The severity provides an average of the KPI where 0 represents the good and 100 represents the bad over the specified time period. The severity is the calculated average of the all KPIs over the scan report period for a given sensor VPA value. So here if you see, these are the two bar, one bar is the severity bar and one bar is the percentage bar, which can be sorted as per the requirement. The severity bar chart percentage value indicates the number of occurrence over the specific time period. The percentage is calculated as the number of non-zero KPIs divided by the total number of KPIs over the scan report period for a given sensor VPA value. It has the ability to generate the report, so it provides some additional kind of feedback with a greatly expanded dataset, which increase the ability to identify the problems. Even we can insert our observations here and we can give some recommendation with this reports. So how this QCS VPA channel is being configured on the site. So once we visit the site, we will connect the DL400 to the OPC. It can be also be connected to the third party system if we have if we have third party QCSs, if we have this data available. Like we should have a CD, MDS, MDL data, and we should have a production data available to be logged. So once we verify the connectivity, then we can create a tag list. This tag list is the standard one if it's an ABB QCS. If it's not an ABB QCS, then this tag list is like the OPC path and everything will get changed based on the connectivity what we get it. Once we create the tag list, we can create a logger session which will log the data. We'll wait for a day. Once the data has been logged, we will verify it whether the data collection is there. And once the data collection is there, we will analyze that config file and we will set up the limits. We will create the grade groups based on the requirement. This grade group can also be modified later. And we can set some limits also over here. And then we verify that config file. For the VPA data, we need to wait for 1 month to analyze the data. Once we have enough data to analyze, we can create some task scheduler. Those task scheduler this updated the VPA config file. Then we will run the QCS data runner. What QCS data runner is do is like whatever the 1 month data has been collected, it will be populated into the dashboard in a single time. And next time, no need to run it. It will be keep on analyzing the data on the daily basis. We will validate the channel operation and then service port is ready to use. Later on, we can also create some of the track rules based on the requirement to identify some of the known issues or some of the issues what we have to monitor based on the analysis what we have done. These track rules can also be imported directly if we have some saved one from other sites or from the previous experience. So how this service is delivered? The ABB application server is a remote enabled service delivery platform that provides a custom secure connection at ABB service and experts. It is deployed at the customer location. The application servers enable delivery of local and remote services and provide both customer and ABB service experts a real-time view of the KPIs as well as diagnostic and the QCS data. Data collected is highly secure as it remains on site and requires user authentication to view. So until or unless customer or the user won't define any authentication, it cannot be exported to the outer worlds. Performance optimization for the QCS service can be applied to any ABB QCS with OPC connectivity. These views are associated with the analytics and KPIs are now made available for use in external application. The service connection platform now makes use of these channels for expanded access notification and usage. This is the demo. It's a live demo of the service port. This is the channel lineups. Here we have all the channels configured. So if you have multiple channels or if you have all type of QCS channel, even you can have a low performance channel. You no need to buy a separate hardware. It can be configure on a single service port hardware. You can configure all the channels. Even you can configure the multiple paper machines provided it has the OPC connectivity. So even you can add multiple 3 or 4 whatever the paper machines you have. Then we go to the data view. So as I have explained in the presentation, this is the data view where the raw data is being captured. The top bar captures the total value and the bottom bar captures the CD, MDS and MDL values. Here you can define, we have the grade groupings which will be defined during the configuration generation. Group 1 represent like some of the GSM groups we can define over here, and then some of the different GSM groups define over here. This is basically to identify the issue in a faster way based on the grouping. So the drop down is having a value of total, actual and target. So the top bar can be changed based on the requirement. If you can set the target, then it will display the target of the real caliper, and if you show the actual, then it will display what are the actual value we are getting. The total will get the data from the report. So one of the best views like the data points, you can see when the data is been fetched. If you see any gap between the data, then it signifies that the service port is down or the connectivity is not proper. So that's why we are getting a zero data over here, or non-zero data and any data. Then we have a percentage of process. This percentage of process is a tool which will help to identify the issue in a faster way. Then these are the KPIs. You can just select expand all, and these are the KPIs which will be shown here during this particular day. So we have CD sigma of sigma, best fit line slope, percentage of process limit. Here we can see the KPI value, the actual value and the threshold. This threshold can be defined during the configuration file. Even we can change at the later stage also. Multiple sensors can also be selected. If you want to monitor the real basis weight and the dry weight, then two sensors or the three sensors. If you want to monitor with the real moisture, so 3 can also be selected based on the requirement. This data can be copied to the clipboard for the further analysis if required on a offline system. Then we have an event view over here. So event view, as we have only one group defined, so we have only one group over here and the all data in the groups. If we have a multiple groups is been configured, so we'll have a multiple columns for the grade groupings based on the configuration. Here we can have option to select from the daily, weekly, monthly and quarterly and yearly view. So the top part shows the CVAT based on that. So if you select this data point, then it will go through it will change the date from which period to which period it's been analyzed. So these are we have selected the weekly view. So based on that, each weekly we can go through over here and there. And then we can just come back to the latest one. So here, if we see whatever the measurements has been configured, so we can have a look over here, what type of measurement has been configured and which needs to be addressed on the top priority. It has been mentioned in the increasing order. So which is having a low issue, it's been displayed at the bottom, and which is having needs a higher attention, it's been displayed on the top. So we can see, okay, if the issue is with the real gap sensor or with the sizer gap, we can just select it and can go to the required page. So let's select this one and then see, okay, we have an issue with the sizer hash. Once we go it will give a detailed window which type of KPIs are exceeded. So it says the CD percentage of process limit is like 100% and the total percentage of process limit is 100%. And the MDS, MDL, these are like 145%. So we can just, okay, this one is exceeded. So we can go to this one and we can see which one is contributing, like MDS, MDL among CD. If you see the CD variation is more. So CD and MDS is contributing. So that need to be addressed on the top priority. So based on that, this can be categorized. Here, these are the limits and the goals, which defines the bar graph. Like we will set some of the goals and limit in the configuration file, and if it exceeds, the CD is exceeding the limit and goal, so that displays the higher bar, and if it is under the limit, then it displays the lower bar. Here, if you see, the total is increasing and the major contribution increasing the total is the CD part, and the NDS and MDL is still under control. So the CD variations are more for this sizer hash. Either we have to fix the CD hash. I don't think we do have any solution to do it. But if we consider this in case of the basis weight, so if you see the total is getting exceeded, again it's a CD variation. So CD variation has to be fixed on the priority. Once we fix the CD variation, the total variation will get reduced and the both will come under the limit, or maybe they're under the desired goal. Then this is a track view window where we can configure a new rule. So can create a rule. We just need to define it, like what type of rule we would like to generate. If we want to monitor any CD data for a particular group, any particular KPI, if we want to monitor, then based on that we can generate one track rule. If we want to have like CD greater than 0.5 for group 1, then sigma is higher. You can set as a priority on the high side. Then you can select a condition like it's above the threshold. You can select the data in the groups for the particular GSM range. If you are monitoring for the old data in the groups, then you can select. If you want to monitor data, then you can select a particular KPI, like for the real drive rate you are monitoring, then which one your CD you are monitoring, and then you can put like 0.5 here, and you can create a rule. So once the rule has been created, you can just save it. Once the rule has been set, alert, the rule has been created here. Even you can create one more condition over here. If you also want to get it linked with some other condition, then you can select some other condition also, like standard deviation of all data in groups, the data, just a real drive rate. So if you want to see, okay, the variation within the CD is also should be like within 1.0, and you create it. So it says that here. So once this both condition gets true, then only this alert, this rule is getting violated, and we are going to get the alert. If one of the condition is still 0, then this rule is not getting violated. So to change this, we can do like any, then the add operands will change to the or. So any of the condition will get true. So we will get the alert. We can just save this one, and then we can have a loop that CD2 sigma is higher one, and we get the alert. We get the rule created over here. So even we can create it for the shorter time, just for the monitor one, and then we can deactivate it based on the requirement. Even we can reconfigure it if you want to change something, or if you want to change from N to O or any other condition. You can even also delete this one, and then you can also go directly to the log, how many times it's been triggered. So if you see this rule has been created and this has been triggered 3 times, so you can just directly navigate through this, and you can have a log, how many logs are there. Even for this time period, this has been triggered only 1 time, so you have the log over here. So this one is the log view. Even you can filter it based on the priority. You can select the low, medium, high priority, and this high priority will show you like how many rules has been triggered over here. If you just uncheck it, so it displays only the high priority rule. It will diminish the, it will remove the medium priority and low priority rules over here. This is the event view, the overtrend or the top trend over there. See how many violation has been done during this period. If you go to the quarterly view, then you see this is only one, which is the high rule, which has been violated over the quarterly view. These are the data points. If we select, it will take you to the previous week rule, and you can see during this period this rule has been triggered, and this was the log for that rule. This is the detail when the rule has been triggered and what is the severity and what is the description. This rule will also go to the email if the email settings has been done. Then the log view, as I explained, this already I have explained the log view. We can come through this log view from the configure view as well. And then the last one is the Pareto view. So Pareto view will show so the counts, how many times the rule the configured rule has been triggered. So weekly real moisture MDL for the sensor is been greater than 89%, almost three times during this time period. And this the rule what has been configured is triggered only 1 time. If we have a different priority rules, then you can have a different colors of the number of triggers are more, then more triggers will come over here. So based on that, we can see, okay, this rule has been violated more times and it need to be addressed on the priority. You can also give the lower priority to the another test rule and keep in mind, but first to address this, then you can take a priority, or maybe some of the rules will get automatically resolved when the higher priority will get resolved if they have the interdependency between them. And the last part is the report configuration view. So in the report configuration view, you can just select the start date and event date. If the customer has called you for some type of analysis for a week, then you can just select the date under the dead date what you have been analyzed. Then you can push the customer name and the all the details as required. Then if you have been on site to analyze the issue with the real moisture and in the real in the sizer basis weight, then you can select two particular sensor, or even if you want, you can select all the sensor, but it will flood the report with more of the data. So better to have the sensor which is been more focused in the during the visit. You can generate the report. Once you generate the report, it will get saved in the doc file. You can save it at the required place. Once the report is been saved, you have the report, and in the reports will look like completely like this. So it has the legends and everything, whatever that it has the contour map view, and it has the detail of each of the KPIs for each of the sensor parameters over the specified period. It also has the appendix which gives the explanation about what is the real variability, MDS, MDL. So it is very easy for the customer also if they want to have some type of glossary to understand. It also gives the calculation behind the rules which has been created, and what it also helps, like when the customer need to be focused, it gives a detailed idea how they can also address the issue by self or with the support. So this will, if this file is created and it gives a pop-up to, if you want to open the file, if you click it as, it will open the file. Here I will click it no. So even you, how now this, the next step is how to create the track rules which can be triggered to the email. So there is an option. If you click on that, you will get pop-up window. You just need to assign the password. You need to enter the password. Once you log in onto the window, you can have a view over here. So this track rules has been shown for the loop performance, system 800XA, system 800XA VPA. Like it depends on the what type of channels we have configured and how many machines we have configured over here. It has the sensor stability, like LV type performance and everything. You can just go to the VPA channel, and once you go to the VPA channel, these are the rules which we have configured. And if you want some of the rules to be monitored through the mail, then you can just select that rule and just you can subscribe it. Once you subscribe it, you can just assign the frequency, and then you can just assign the email. Once email has been assigned, the rule has been created. Basically, yeah, definitely you need to create the SMTP settings for that, which can be done when the system is installed. It has the priority to import these rules. If you want to utilize for some other machines, then these rules can be imported and can directly the new rules can be imported here. And these rules can also be saved for the future purpose. You can directly export it and you can keep it for your record, and when the requirement is there, directly you can import over rule, and both the service port and this machine will get syncs automatically. And you can also view over here. You can just click it here, and then you can you can just see the summary of the track rules when it's been triggered. If you have the multiple triggers, then you will have a multiple list over here, but the rule is triggered one time, then you have a one list over here. And even you can export into the CSV files and can use it and can for some other analytical or some other analysis. It gives the alerts if you are having some it's have a, like if you have any error to send the mail, then it will show you an error over here which can be resolved. Thank you everyone for joining. In case you have any doubt or you need any support, you can always send me a mail or can ping me on the Teams. See you later.